So in this video, we're going to be covering the Array.prototype.reduce method. And this one, I don't really use that often, but it is pretty useful if you ever need to aggregate all the elements of an array into a single type of value or sum up all the values of an array into a single sum, etc., stuff like that. So this one's very similar to map and filter in that it takes a callback, and that callback is going to have a couple of arguments that you have access to. But something that's different is the second argument is the initial value of the reduce method, and we'll talk about that in a second. Basically, again, this function returns a single value or result, which is going to be your accumulator after it returns out of the callback function. The initial value is going to be the first element in your array if you don't actually provide a value here. So if you notice, I have this in brackets because that's an optional argument. The only one you need to pass in is callback. Notice that this will not modify the existing array. That's good to know. And then the callback arguments are this. You have the first one is the accumulator, which is kind of the value that you're summing up or aggregating over time. You have the current value of the index that you're looking at. And then the second two are optional arguments. You have index, which of course is similar to filter or map. It's just the index that you're looking at, which corresponds to the same value that you're looking at. And then you have the original array if you ever, for some reason, need to access that array inside of your callback. So with that being said, let's go ahead and look at some examples of how this may work out. So the first most basic example would be using the reduce function to sum up all of the values in an array. So to do this, we need to pass it a callback, which has the accumulator in the value that we're looking at. So remember, there's two arguments for the callback that are required. There's the accumulator, which I'm going to denote as A. And then there is the value that you're looking at, so I'll denote that as V. And again, I'm going to pass that an ES6 fat arrow function, which is going to return every value added to the previous sum. So the thing that's hard to understand about reduce is that the A value is going to be equal to the returned value of the previous call. So for example, if for the first iteration we return 2, on the next iteration, A is going to be equal to 2. And we'll step through this and it'll make more sense. But what we want to do is we want to sum up all of the values together. So how would you do that? Basically, you need to sum up the current value with the previous sum that was running. So if I just return the sum or the accumulator plus the current value that we're looking at, that should return us all the values summed up after reduce is done running. So let's step through this. I don't think it made 100% sense yet, but it will when we step through it. So if you remember, we're calling reduce without an initial value, which means that the initial value is going to start off as the first element, which is 1. So we're basically going to start this loop or iteration at index 1 here, which is value 2. And your accumulator is going to be equal to 1 on that first iteration. Again, this is because we did not provide that second argument, which was the initial value, which is optional. So for this first step of the iteration, we're going to have value of 2. And we're going to do A plus 2, or A plus V, which is 1 plus 2, is going to be equal to 3. And I'll just go ahead and keep track of that somewhere over here. I'll just put a 3. And what's going to happen is now that this is going to return 3, on our next iteration, when we're looking at this index, your A is going to be 3 at this point. Because A just continuously updates to whatever you just returned from the previous iteration. So then V will be 3. We're going to sum those together, and that will be 6. So let me just set the next iteration. And remember, A is now 6 because that was the previous thing returned. Now at this point, V is going to be equal to 4. So 6 plus 4 is equal to 10. And then we're going to return that since we're at the very end of our array here. So our value is going to be equal to 10. So hopefully that made sense. I'm going to do another example in a second, but let's go ahead and look at JSBand and kind of walk through that same example. So again, over here we have an array with 1, 2, 3, and 4. We're doing Array.reduce. We're passing it a callback function which has an accumulator and a value, which I can do A and B here if it makes more sense to match the example. But I'll spell it out since I have more space to write. It's more representative. And what I can do is when I run this, it's going to print out 10. So nothing different from the example I showed, but this is basically how you write it out in JavaScript. So let's move on to an example where we do provide an initial value. So now I wanted to demonstrate the initial value argument that you can pass in. So what I'm going to do is I'm going to write a new function, which is just going to multiply all these together. So if we have A, which represents the accumulator, and we have V, which represents the current value that we're looking at. And that's going to be a function which basically says accumulator, or return the accumulator multiplied by the current value. So if we were to run this, it's going to do 1 times 2 times 3 times 4. And we are going to step that out in just a second. But what I wanted to demonstrate is that there's another optional argument you can pass in, which is the initial value. And we can set that to whatever you want it to be. So in this case, we could set it to 10 for whatever reason if we wanted to multiply everything by 10. So let's just go ahead and do that and kind of step through this. So since we provided that initial value, at this point of the iteration, we're going to actually start at index 0, which is going to be 1 for our value. But the one thing to notice is that our accumulator is going to start at 10. That's because we passed in that initial value of 10 here. So if the initial accumulator value is 10, and we're looking at index 0, which is value 1, we're going to have a 10 times a 1, which is going to return a 10. And then our next iteration will start with a 10 again for the accumulator. So we'll move on at this point to index 1, value 2. The last return value was a 10, and now we have 10 times 2, which is going to give us a 20. So if we go back, we're now going to be at accumulator value of 20. We increment our pointer to index value of 2, or index 2 value 3. Now we have 20. 20 times 3 is going to give us 60 here. And then same process. Now our accumulator is going to be at 60 for that next iteration. So we're up here, value 4. 60 times 4 is going to be a 240. And now that we're at the very end of our array, we're going to have a value of 240 returned. Again, the main takeaways was when we provide an initial value here, it's going to set that as our accumulator value, and then we're also going to make sure we look at index 1 when we do all of these operations. So let's go back and verify that we do get 240 with this callback function. So inside our array, what we can do is instead of adding them together, we can just times them together. And I'm going to pass in an initial value of 10 here, just to show you that we get 240 back. And again, you can change this to whatever you want. So if we did an initial value of 0 and we times everything together, guess what the value is going to be? 0, right? Because we did a 0 times something and we're timesing it all together, and it's going to become 0. We could do a -1 if we wanted to kind of make all this become negative. So -24. And again, that's because we did not do the, if I did -10, it'd be -240. So, I mean, this is sometimes useful if you wanted to do something special with the initial value, like you actually needed to process 1. Or sometimes if these are objects or characters or something, you actually want to look at the initial value here. So typically you'll just like provide an empty object or whatnot. Or let's say I wanted to do like a percentage, right? I wanted to times these all together and give back some percentage. I could just do that. Or sorry, I could do 001 to get back 0.24 instead of 240. And so just so that we understand what's going on, let's just do one last example where we have characters in here. So A, B, C, D. I'm going to go ahead and get rid of all of this stuff keep the callback function. But for this last example, again, we have characters A, characters B, character C, and the character D. And if we wanted to concatenate those all together, we could use reduce to do that. Again, if you want to aggregate all the values together into a single return value, reduce is a good method to do that with. So again, in this case, our accumulator is going to be the first value here, which is A, and we want to concatenate those all together. So since these are all strings, we could simply just do an A plus the value, which in our case would be like the characters. So let's step through this really quick and kind of make sure we understand what's going on. So since we did not provide an initial value, our accumulator value is going to start off with an A, and we are going to be starting at index 1 to look at this. So value is going to be B. We're going to do A plus B, which is going to give us the string concatenation of A, B. And then so on our next iteration, we're going to move on to here. Accumulator is going to be A concatenated with B. The value is going to be a C. Write this down here so it's a little bit easier. And we're just going to concatenate those together. So AB plus the string of C is going to give us a C. Pretty straightforward. And then we move on to the next iteration where we're going to be looking at the last index, which is value D. So we have A, B, C. We're looking at value D here. And we're going to concatenate those together, which is going to give us the end result of A, B, C. So again, this example is pretty similar to the very first summing example we did, but now instead of summing, since these are both strings, we're just going to concatenate them together. So if I go back to the JSBin example, I could change this to an A, a B, a C, and a D. We want to add those together, which is going to do a string concatenation. And when I run this, we're going to get back the full string of A, B, C, D. So nothing too crazy about this function. It literally just calls a callback function and does some type of operation to combine all of your elements together in some way. We could do an initial value here of like a hyphen if you wanted to prefix this with a minus for whatever reason. Or if you wanted to concatenate them in a reversed order, you could just put value plus accumulator so that everything is reversed, ECBA. So a lot of cool stuff that you can do with this. So I'm going to do one last example actually, just so we really understand what we're talking about. So if we go back to the example where we're doing 1, 2, 3, 4. So 1. Actually, in fact, let me just kind of change this up. So I'm going to just do some random numbers. So 5, -2, 0, and 7 or something. So let's say for whatever reason we wanted to find the greatest value in this array. You could again use a reducer because you're trying to take an array of 4 elements and return a value that's going to be a single result of one element, right? So reduce is kind of a good method to solve this problem. So what we can do is in our reduce function, we need to continuously return the max value that we find. So inside our callback function, we could just simply do math. If you're familiar with the JavaScript math library, you do math.max. And then we're going to pass it the accumulator. And we're going to pass it the current value that we're looking at. All right, so let's kind of step through this to make sure we understand. Again, we did not provide an initial value, so we're going to start at index 1. And our accumulator is going to be 5, right? Ultimately, the end result should be 7. 7 is our max value. But we're going to be looking at 5 for our accumulator, -2 for our value. And then we're going to call that or pass that into a function in math.max, which is going to return the max value of both of those. So what is the max value between 5 and -2? Well, it's going to be 5, right? So then we're going to move on to our next step where we have 5 for our accumulator, and then we have value 0. Same idea. What is the max value between 5 and 0? Well, it's going to be 5. So accumulator is going to remain 5 for that last part of our iteration. And then we have value of 5 and 7. We're going to return the max value between 5 and 7, which turns out to be 7. So our reduce function will ultimately return 7 at this point. So let's go to JSBin and try that out to make sure we understand it. So 1, I think it was 5, -2, 0, and 7. And again, what we need to do is just return the max value between the accumulator and the current value we're looking at. So if I do the max value between value and accumulator, notice that it returns the value 7. Cool. So again, you can do a lot of cool stuff with reduce. You just have to understand when and why you might want to apply reduce instead of just doing like a typical for loop or something. That kind of wraps up this reduce